Oh, still have my socks on. Well, in honor of my spirit animal, Gary Vaynerchuk, might as well start somewhere. Hi there, my name is Joe Drake, and I'm the founder of Mechanic Man Manufacturing and the developer and creator and manufacturer of Filter Buddy, a filter change's best friend. So, on this journey, through looking through research, I really couldn't find a whole lot of ways to make 3D printed molds that could readily be used back to back, clean, self-clean themselves. Like, a lot of what I found was what I would call hobbyist level use of 3D printing, which is a manufacturing process that still blows my mind. And I'll get to that later. But creating an actual product from a 3D printed mold and then scaling it to a semi-industrial level is possible. And on this journey, I would like to break down what I did to go from completely leaking, dysfunctional, messy, one-time use systems that give you subpar results for, if you're gonna make one part or a couple, you might get away with it, but then it becomes messy and tedious and expensive and material consuming from this to a finished product, which can be used over and over again, completely clean. The chaff that you remove from your final pieces is easily discarded. The final pieces are easily trimmed, and you can do this process back to back to back to back to back as fast as your material can cure. This is a RTV-2 or a room temperature vulcanization rubber, silicone rubber. 2 parts, an A and a B of equal measure, and over a period of about 2 hours it cures and it turns into this semi-hard rubber material that is extremely hard, and it's a ready-to-use, ready-to-sell tool that I have developed, and my complete manufacturing process is based off of 3D printing and being able to do it back to back cleanly and at scale. I can make 198 of these a day if I were to turn up to full capacity, and I'm going to share that with you guys. I'm going to try to give you the deepest, best explanation of how to accomplish this, because I feel like a lot of people just, I'm this company and, boom, 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 this is how you do it, and just figure it out. So there is a lot that goes into the engineering of, again, making stuff like this where seals fall out and things don't vent properly, to bubbles, to you name it. It had to be fixed to come up with this finished product that, like I said, you can back to back do this. If you add a couple of engineering pieces to this that I will go along with you and describe in detail, you can make these infinitely usable to the point where the typical hobbyist, for example, if you're into cosplay, which I think that is a huge, awesome market of people that spend a lot of time, creativity, and effort for one-off costumes that they maybe wear for themselves, or maybe make a couple of parts for other customers or people, but are really limited to making those unique pieces because of the lack of the ability to back-to-back produce them with a system that's effective and cost-effective. You're not wasting a ton of material. This is all of the chaff that you get, and you can cut costs, and you can make that number even smaller due to what you're trying to accomplish. And during this seminar, I'm going to give you as many tools as possible in as much detail as I possibly can. So that way you guys can go straight from watching these seminars to, I can do this, I'm going to tackle this, and all this stuff that you're going to be able to do, you can get from Amazon or Home Depot. And turn you guys loose. The sky's the limit, and I'm going to show you specifically how to do it. And gotta be sure I remember what I'm doing. Gotta have bloopers too, because gotta write this shit down. Okay, so moving along. So as far as creation of one of these molds go, you gotta start off with the basic fundamentals of just having some mechanical aptitude. If you don't understand mechanics and forces and chemicals, you might want to spend some time, diving into that. You don't have to go crazy with it. When you all have free time, you're sitting on the john. Nobody takes a dump without their sorry, I shouldn't say that. Nobody, goes to the restroom without their phone anymore. You've got 30 seconds to Google something. Curiosity killed the cat. But we're going to start basically with the idea. A lot of people will get shut down on ideas because people will say it's stupid, or they get subconscious about it, or you may reflect back on it thinking it's not a good idea. But if you can come up with an idea nowadays, especially with the world of technology and having phones to record and having 3D printers that are really cheap, deliver them to your door, there's really no excuse for you not to indulge in creating something as a creator, as a human, do something for mankind. I know this isn't free energy, but this is a different look and a tool to be used on an age-old thing that I've done as a mechanic since I was 10 years old. Is if you're going to change a fluid type filter, a hydraulic, oil, coolant, it doesn't matter, diesel fluid, when you crack it loose, it goes over you, the machine, your arm, and that is just nomenclature. It's been that way for seems 100 years. And the tools nowadays are super subpar, I feel, to accommodating, just keeping that contaminated stuff off of your skin. Now that we're learning about carcinogens and stuff like that, mechanics wear it as a badge of honor to be the dirtiest guy, either in the morning or at the end of the day. And when you're 50 years old and those chemicals start to show in your body, there's proof of it now, we're going to start to think otherwise. So indulge in your creativity, indulge in the possibility of making something that the other 8.8 billion people would actually like to have on this planet and to use. It doesn't have to be something like a tool. It can be art. It can be a new way of developing something or designing something. It can be a new fashion style. I'm not very fashionable, as you can tell. I'm a race car guy and a tool guy, and that's just kind of how I function. But I implore you to try. If you think that you have a good idea, if you think that you have something that might be a good idea, follow the link. I'm going to try to figure out how to do that. This link somewhere here, there. And tell me if you have an idea that you don't know how to get started, or you have a hurdle that you really can't come over, drop a question in the link, send me an email, find me on my social media somewhere. I have like 5 platforms that I'm pulling all my hair out to do, so that way I can entertain you guys with the newest and latest information for this, with cars, with tools that I'm going to make in the future. And I will bring you along on the new production of Filter Buddy LG, which is for sale right now in the pre-sale. If this Filter Buddy doesn't fit your application and size, I have the next size upcoming, finalizing mold design and getting it produced. And I will be right back to doing what I was doing with these guys, making them, and when you see them by the hundreds, using 3D printed molds. And I'm going to share it with you. So again, stay on top of it. If you have a dream, do it. I highly implore you to do it. Find out how, make a plan, make a window, and execute it. And no excuses. It's scary, it's daunting. You have to start somewhere, and you have to stay consistent. You're gonna fail. If you see down here, this is the small box. I've thrown away probably 5 times this amount of wasted material that just failed. You learn shit along the way, and it can be timely and cost effective, or cost consuming, and just an all around bad time. So my goal here is to inform you as much as possible. That way you don't have to deal with this. You can go straight to designing the best mold that you can for whatever it is that you want to make. And we'll get to kind of designs and sophistication here momentarily. All right, moving on. So my mold design is for Filter Buddy. This is for fluid filter removal to catch all that nasty fluid when it comes out. No, you're up here, you got your head up your butt and you're doing the little oil change, and then you crack the thing loose and it just goes over your arm and you're like on your face, and you spin it too fast and it gets in your eye and you're like, why? And the old man above you that's teaching you how to do this is like, you gotta learn somehow, while you got like poisonous spit oil in your eye, burning your vision out. This is my take on it, and I know that there's a lot of naysayers out there like, oh, I already got hit with a whole bunch of them, just trying to be nosy, like, oh yeah, if you would you drop your purse? Like, no, it's having an idea and taking the steps to bring it to fruition. I know it's not free energy, but people around the world can use this to safely change your oil. Stuff's hot, man. If you're a diesel mechanic and you're doing hydraulic fluid too, especially if the system is still pressurized, if you had this on there, then you wouldn't have got sprayed in the eye. There you go. LG will be great for all of you diesel guys as well. Perfect for the fuel filters, the oil filters, and I'm going to make bigger ones, so you just stay tuned. Anyway, my mold design is based off of this. Now, it's rather sophisticated. I don't know if you can see it. I would think sophisticated due to different edges, different fingers, different widths, different depths, and all of this has to be liquid as it comes up from the bottom, and be successful in trimming all of this stuff away when you're done with it, and make sure that you have all of the bubbles out of it so it looks like a very nice, bubble-free, strong, ready-to-use product for when you change your filters. It completely encompasses it. And this lip here is designed so you can use it at 90 degrees, because the filters that are designed with this don't have a whole lot of fluid that will be coming out of it. They're usually going to be these smaller type filters, so under the right circumstances it can be used that way. But for all the other guys that are upright, when you're doing this, completely encompasses it. It goes into these channels, as you can see here, and you just pull that dude away. And then you take a new one, you slam it up in there, and guess what? I even did a white glove oil change because it is possible. I just want to let you guys know that. If you ever wanted to be that cool guy, if you're working on Lambos, you're doing, I have an R32 GTR and that's what I use it on. I want to look professional. I want to make sure that people know I have the right tool for the job, because a PC1000 doesn't sound so good when you're telling them you used a paperclip to test electrical leads in the car. Anyway, back to the purpose here. So, mold design. Starting out, you're going to have this product here. And your total mold size, obviously, is going to be relative to the size of this. So, for demonstration, this is an older model. This is the center section of what is a 5-piece mold. Now, this is 3D printed. These are 3D printed threads. All that stuff I'll explain a little bit later how you can accomplish that. But this is the center section, and this essentially is down in here, and you pull this out of this center section where these are the fins, and you can see kind of the round circular design on the bottom, and the round circular design of the fingers. That is to help grip filters. Also different sized filters. It allows you no magnets and nothing. It grips it, holds on to it, gives you as much grip as you need to go ahead and screw that filter loose and back it out of there, hold all the fluid. So the center section, as you can see, has vent holes in the top, as well as the top portion, which will be the top, has the vent holes as well. So this is where this chaff comes from. And I'm going to do my best to describe and explain how you can accomplish proper vents while having O-rings to keep your system completely sealed. That way there's no leaking, there's no major cleanup, and the trimmings, I don't have any that actually have trimmings on it. Yeah, I do right here. So as you can see, these are the trimmings. This is where your linear gasket would be, so in here. As you can see, there is a 2mm round rubber stock that you can get from Amazon. You can get it however long you want. And this is pressed into a groove that is designed right into the 3D printed mold itself. And it is a linear seal that is cut off fairly flush with a little bit extra. And that seal surface meets up with this outer rubber seal, so it creates a union there where it completely seals. So if you think about it, as these are together, here's your inlet at the bottom. Now this is a, is it a 1/4 inch? Yes, it is a 1/4 inch NPT thread. So, okay, and again, while I do this, if you guys have any questions that I'm not covering, go ahead, drop a question in the comments below, send me a link on social media, private email me, do whatever you gotta do to get a hold of me. I'm pretty open. I like to let people learn this stuff because I know that there's a pretty big gap in knowledge that people are missing out on, and I think that for the people that want to do other than hobbyist stuff, this is a perfect way to mass produce. Well, what would you call it? Semi-mass produce, semi-industrial. You know, if you're making a couple hundred of a product that you can make 10, 15, 20, $30 on a day per transaction, you can see where the numbers add up exponentially. So back to what we're doing. Bottom feed here is a 1/4 NPT, as you can see. These thread in here nicely, and this wasn't trimmed at all. This was all done straight from the printer. Now the printers that I use are Ender 3s, somewhere over there. I'll have to give you a little side cut video as I edit these together, give you a little view, you know, little aesthetics as to what it is. But these are hooked to a valve that go to the bottom of this mold, and that will be for episode 2 of this little tutorial. I'm going to focus on mold production and making sure that your mold is going to be the best that it can be for this episodes. And then if you subscribe to the mailer, you will get a notification when I release the next video, which will be this guy, or this guy by now. I don't know how it works. I'm still trying to figure that out. And it will be more of the other side of what makes this method so viable in reducing a mass quantity of parts. Okay, so back to the basics. We fill up from the bottom. We have our linear seal in here, keeping our 2 halves of our product completely encompassed. So when it's in there, it's doing this. This is how it sits together. And as you can see, it has a seal here on the very edge. Or as you can see, these little chaff marks, which they pull off really, really easy, and that's designed on purpose. This surface here is that edge, and it is so sharp that when you pull these out of here, you're going to have a chaff line or just a casting line. And as you can see, you pull these, they just come right off. So you just trim it, and you're good to go. So making sure that your clearances are super tight, but leaving enough between your gasket, that way you form these little removable chaff lines, and that's what this is. This is all just kind of slag. So, okay, so we have our product. We fill up from the bottom up, and that's a whole nother process that we'll describe later, is the degassing of your fluid and how you're going to deliver it into the bottom, because what I use here is a 30A shore hardness from BB Dino, which is an Amazon A and B silicone. They'll ship it straight to your door. I believe that it is like $134 a gallon. So the stuff isn't cheap. And through usage, you can obviously get deals and stuff that you get 12% off coupons or whichever, which definitely helps in the end of your production. So if you can get with your supplier and let them know what you're doing, if you tell them, hey, I've already ordered a dozen gallons and I plan to continue to do this in the future, usually they'll hook you up. They'll reach out. They did for me. They got it down to an excellent price that I can effectively produce these, make a profit, make them at scale, and do it all right out of my house. So you will put your fluid under pressure and push it in up from underneath, coming up. And where that starts, if this guy is in here, I can't really put him back in there, but it starts here and it goes out and then it comes around and then it'll just flow up. Now, on top of each of these fingers, if you will, there is, I don't have any that aren't trimmed because I trim them all. Well, there's chaff. There will be silicone that hardens and a 2mm hole here. As you can see, these holes are all vents. So these are the highest points within my structure of my part that I want that would obviously capture air as the fluid rose up. And these are tapered. They have a roundness to them to allow air to come out as smooth as possible. So, and that sits in here like that, okay? So as you can see, I've made these by the hundreds and they come out the same. You trim them, they look great. They say my name on them, say the factory, and you can do this at home in your garage too. And pushed all of the air out, it comes up through the top holes here of our center section, because that is our cavity for the part that we want, and it sits inside here. That's where this solid fluid structured piece comes from, is in here. So now that the fluid has come up, due to the fluid, the temperature, the humidity, and depending if you off-gassed your fluid or not, will depict if you have a lot of bubbles or not. Now, I highly, if you're doing this as like you mix it A and B into a cup, which I'll describe that in the other seminar in more detail as far as your material care, if you will, how to handle it, best way to get the best results. You're gonna want as few as bubbles as possible because they do show up and they do cause problems. So the less bubbles that you have, the better part you have. Ultimately it decides whether or not a part is sellable or usable, because if the bubbles are big enough, you'll get things like this. As you can see, these bubbles, this edge just looks like crap, and that's all bubbles. Just either through the process, not degassing, excessive mixing, all of that plays into it. So I will cover that in the next one. So if you feel like that's something that you need to be more specialized on, is the care of your material, go ahead, follow me, send a link, do something, get a hold of me, or at least subscribe to what I got going on here at my website for Mechanic Manufacturing. Give Filter Buddy a good gander and a look, and if you feel it's something for you, try one out. Go ahead and order from the website, and I'll give you a mailer, coupons, all kinds of good stuff. So there's always something going on there, stuff to see in the future, and obviously links and notifications when I release more of this info on how to do all of this awesome stuff yourself. So please like, share, follow, all that stuff. Anyway, so back to fluid is moving up. So now we have our top piece. Now, if you're thinking about orientational, as far as where your pieces have to be in space to make sure that you get this. Now, when I mean that, like same thickness of walls, the thing doesn't shift, it doesn't get off-centered, you don't have this bottom corner touching this inner wedge here, right? You want this to be square and centered in space so that you have a good, uniform, usable product. So what I have developed here for the sophistication of this mold, now, again, if you're just making like a bouncy ball and you hit up just a rubber sphere, you can make this out of two pieces, and the same principles that you're gonna learn here can apply with the linear seal, a round rubber seal. You know, look on Amazon and find what you need, and you're gonna learn the tools on how you measure and make this stuff. So like seals like this, they don't fall out, they stay in there with pressure and everything like that. So Moving on, top section here. So as you put this in here, you tighten it down. Now that squares your center section to the top. Let me back up here. As you can see, there's this inner rubber seal. Now your fluid is going to come from out of these two holes mostly, and then there's going to be a small thin layer that comes from here. I designed that it's easiest not to have a seal there because due to cost, the ease of removing that chaff particularly, it just was best for me not to do anything. So this, as you can see, this line here, there's just a little bit of goop from the last time using it. That is this O-ring surface. So that squares this up, true. And then this nut here tightens down on that, and that seals what would be the inner portion of those vent holes from it leaking out the center here, and that is its only means of escaping. Now the outside is this 110 millimeter O-ring here. It's another 2.5 millimeter diameter rubber stock O-ring, and it seals up against our linear seal. So now our fluid channel is completely encompassed. Now that's important to remember when you're designing your mold for the sophistication of the part that you're trying to remove. If it's simple, like a ball, you can get away with 2 halves, maybe 1 O-ring, and you put that together, compress it together, and hold it. So as you can see here, this is a very small portion of the failures that I had. You know what? These are actually brand new and never used, but I had an issue with them that I'll talk about later, to where, yeah, these are all failures. So don't give up and just keep on going. All right, dang fan turned on. So where were we? Okay, we're back to have our linear seal in the half of our mold, which is going to be butted up against this outer 110 millimeter O-ring that we have here. So in doing so, that allows us to completely encompass our fluid channel to make a solid, clean cavity where our fluid can flow from the bottom up. Now all of that is designed to be square and fit into the bottom of this channel here. Now this is tapered. Hi Turbo, this is Turbo. He's a handsome boy. Yeah. You want to say hi? Speak. Say hello. Speak. 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 Oh. He usually does. I don't know. Are you gun shy? I'm shy too, dude. This is stressing me out. It's making me sweat. It really is. I'm not used to being on camera, and you know, you always have the questions of like, is it good enough? Am I saying what I need to? And I'm just kind of rambling on. But you know what? At the end of it, we're probably going to edit this stuff out, so I'm just going to go with it. Anyway, back to the story. So here's this inner edge, and what it does is this inner square goes around these edges. Now, when you make these edges, I advise you to taper or fillet all of them. Now, fillet is just like a 45. And, or no, taper, fillet, how would you say that? Fillet? I don't know. You're going to round these edges. That way everything kind of molds together nice and neat. Now, the clearances between this face and these outer walls, if you're going to slide this over that, right, you're going to want your tolerances to be about 1 3D printer pass or 0.02 millimeter, either smaller than your inner here, or you know, larger than this. Whichever way you decide to go, you just need to make sure that you have a little bit of that gap in there. Otherwise, you're going to see a lot of stress between here, a lot of times of trying to pound this on, and that will cause fatigue. So when you're playing with your 3D printer and your settings and your gaps here, a lot of that's going to be trial and error for you and your printer. If you're a seasoned 3D printer person and you kind of have an understanding of making machine pieces and making stuff fit for a certain kind of air gap or a press fit, if you will, you're going to be more seasoned to do that stuff. So I highly suggest you just get started, try it, and as you can see down here by this whole mess, you are going to fail. I'm not going to say that this is going to be like, you know, turn and burn. I've spent the last year trying to perfect this at a really decent pace. You know, it wasn't my full-time job. I had a lot of responsibilities in between that, but you are going to spend a lot of time developing whatever it is you need for yours. So I'm just going to try to give you the best kind of reusable 3D printing casting ideas to maybe expand you beyond the typical hobbyist, or to be honest, just to give you the best 3D print mold cavity result when you're doing like silicone injection or anything of that nature. So back to it anyway. So we have our seals. It's going to seal here, right? Labeling your halves left and right, mark them. That way your orientation for your mold is always the same, right? These halves are always here, and this is always oriented. That way, if you do have issues or you notice that there's problems, you can quickly diagnose what's going on. You can even go a step further by, if you have multiple runs, label a section of your inner mold. There are ways you can put labels and words into your molds and have them come out in your products. You know, this says Filter Buddy, so you can put, you know, mold 1 or mold 2. If you have 10 molds, you can label them 1 through 10, and that's a real good way to diagnose issues. If you're really churning and burning and you're making hundreds of parts and you just happen to notice that some of them are failing and it's not really being catched until they hit, you know, ready to sell, they've been trimmed, they've been packaged, and you're like, what's going on? Where did this come from? If they're not labeled, you're not going to know. You're going to have to backpedal, you know, and pull a example, you know, while you're in production. If you do this, you can go straight. If you number or label the molds according to what you're trying to produce, then you can backpedal and kind of reverse engineer way quicker what's going on, where the problem is, and how to fix it. So left, right mold goes in here, slams down. Now, moving forward on the older model here, which as you can see has pieces of it falling apart. These inner pieces don't have, like, they're not holding in there. I actually tried to super glue them, which rubber and super glue does not go together very well. So if you're trying to utilize this mold design or a two-piece, this is, you know, pretty sophisticated. If you were just at a two-piece, you could do just the two halves and bolt them together. What I've done here is these are through holes, as you can see, and I just put a nut on this other end, and there's 4 of them here, and you just tighten it down to where your linear seals, you can get these really tight. I probably will release a little bit of some 3D printing tips. If you go ahead and give me a follow now, later in the season of me releasing these. There's a lot of stuff that you can do with your 3D printing software. I don't know what you're using, but I prefer to use Cura. It's what I started with. It's really powerful. Other people will say you can do other stuff with it, like if you want to get super sophisticated and you're doing all kinds of weird, crazy stuff. I do understand that Cura is getting ready to implement some of the stuff that I thought was missing. So if you want to talk about that, or maybe see what I have to say about it and see all the tips and tricks that I have with 3D printing, check out the video that's coming. I don't know if I have it out. It might be out. You can look here, look there. You're supposed to do the finger point thing and it pops up. You have your clamping left to right. You have your clamping up and down. And you have your injection hole. Now this was a lot earlier in the beginning phase. I was just super gluing a 1/4 inch NPT hose in here and literally using a big giant 500 milliliter a milliliter syringe to inject. These are 200 and roughly 25 milliliters. I think it's actually closer to 200 milliliters to make this entire product, as well as the chaff. And literally pushing it with my hands, just holding it, pushing it, and mind you, it's very hard. You only have about a 30-minute window to a 45-minute window, depending on ambient temperatures, humidity, how you mixed it, how long you let it degas, window, and you were on the verge of having your feed line clog up. I mean, by the time you pulled it, you plugged it, or whatever, it would be cured. So you had a very small window. It's super hard to do. Getting mechanical pressure to push fluid that you mix and you pour it in there, and it's rather difficult. So if you want to know how I do it on a semi-industrial scale, which you can watch the videos coming up, I will describe in full detail how you can go from, again, pumping single-use parts very difficultly to doing hundreds of parts if you so choose. So give a like, give a follow, give a share, do all that business. It's going to be great. You're going to learn a whole bunch of stuff. So anyway, you have your generic makeup of the molds here. Now I'm going to go ahead and dive in a little bit deeper to what I would say is the juicy bits of getting these to work without having a lot of failures, a lot of leaks, a lot of issues as far as pulling apart, sealing issues, construction issues with what you're going to use as far as your scaffolding, and yeah, kind of the 3D printing aspect side of making these molds work properly. So, whew. So before we move on to the finer detail of what makes these molds work really well over repeated times, is I'm going to go to the 3D printer aspect side of what creates these molds here, and how relatively cheap and inexpensive it is, and how you can get really, really great results. I mean, these things look fabulous, have great finishes. These NPT threads, they thread right in. All of these molds are, for the most part, completely trimless. I take them hot off the printer bed and they go straight into production. No trimming, no sanding, no scuffing, nothing of that kind. So let's move over to the printers. So as you can see here, this is my Creality Ender 3 from Sane Smart. Now these printers are cost effectively $200 from Amazon. This one, it has the nice vented enclosure here, so it can run ASA or ABS, stuff that puts off kind of a nasty chemical off gas. Now all of my molds are made out of ASA, or not ASA, PLA, excuse me. But as you can see, they are very effective in creating back-to-back, extremely precise molds. So you don't need a $500, $600, $1,000 printer to effectively put it to use at an industrial scale. If you were to get 3 or 4 of these, you have $600 to $800 in 4 printers that have excellent quality. As long as you set them up and understand the basics of 3D printing, which I may do a video on kind of more of that stuff later, which you can follow wherever, on my social media and my YouTube, where I'll disclose a lot more of that information in the future. But these things are great. Parts are everywhere, pieces are cheap, upgrades are extensive, and for the most part, you can print a lot of your upgrades that are going to make these printers just run really flawlessly for a very long time with minimal issue, and all around really great printers. So again, they do really well at making back-to-back products. All right, so I hope, is this, oh yeah, that's great. Like clear back to here, dude, perfect. Whew. Kind of, yeah. All right, so I wanted to get up and close in detail to show you kind of some of the juicier bits as to what makes these molds work correctly. So, as you can see, these molds are fairly simple. They are a left and a right half for the bottom. These nodes here are locator pins. So as these go together, right, it keeps them locked together. Now, specifically design your halves to be applicable to what you're trying to adjust. So my left half here is more sophisticated and has more features in it, which makes it to where I have to adjust just one half. This one had very small features. I got it finished very early on in the production process, and I'll explain why later. It has to do with the inlet feed being stationary for how we are going to inject them and what in, called the jig. I'll explain that later. If you want to follow along, or if you have questions and you want links to how to get to this extra information, maybe you just want to skip ahead to the juicy parts, go ahead, give me a follow, give me a like. It should be in there. If not, it's coming. So if you wouldn't mind, follow along with my mailer. You'll get some coupons for Mechanic Man Manufacturing, as well as just some other bits to this stuff and future projects that I'm going to have. So follow along. It's going to be interesting. Now, so we have our left and right halves. This one had the patent pending filter buddy. It was really easy to finish its design as far as the pieces that need to go into it. So, locate yours with right, of course. And if you notice here, there's a little tiny pocket that goes down in here, and it has a tiny little wedge. This is tapered here. It's hard to see. Actually, where's my pen? My pencil. Yeah. This taper right here is very shallow, right, if you can tell. And what that is, when these pieces are together and your center section is in here and it has silicone in there, these are somewhat difficult to separate, right? Just like that. When you take this all apart, you're going to separate these two halves, and it'll be like this, and then you got to get this out of that, and your final piece will be here. So what these are just crude wedges. Now, you can do this differently. I found this to be the easiest way. These are robust. They will hold up. I haven't found any issues working it the way that I have. So if you come up with a better way to do this, you can do push pins, you can make threaded inserts, you can do guide pins, all kinds of stuff depending on your application. So the sky's the limit. Don't be afraid to try something new. For me, I have a screwdriver actually that was designed to fit this, that you can push in there lightly and it will surely but slowly separate the two halves, so I can remove it from the jig, which is what I will be describing in later videos. Again, if you want to know what that is and you want to get more into the mass production side of this, go ahead, give me a follow. I'll have links to those videos coming up here soon. So back to our left and right halves. As you can tell, that is the majority of the makeup of the bottom section, if you will. These push tabs, your guide pins, your fill-in hole, these push-out tabs or wedge tabs, if you will. Now, one more very important secret of the bottom half of these molds, of course, is this linear seal. Now, whatever CAD software that you are using will have different methods to apply making this channel. Now, let me get a piece of paper and draw for you this channel, because if you have a round gasket and you have a square channel for that gasket or your round rubber seal to fit in, it's gonna fall out. It's gonna do what this guy's doing, and it falls out really easy. As you can see, it doesn't hold it. It just it's just sitting in there. The first time that you go to pull them apart, no matter, this is probably gonna come out, and then you have to reseal it. You can't have these nicks and these misses and stuff. You want to be able to use this over and over and over again quickly with minimal cleaning and right back to it. So what you're going to do, this is a 2mm round rubber stock inside this channel. Now the secret to these channels is you want your height of your channel to be between 0.8 and 0.75 of this diameter. So I don't know really what the math was. I think it's like 1.5. Yeah, your height is going to be 1.5. That way you have protruding is 25% to 20% of the total diameter of this is protruding past your level surface here, or your square surface where these made up to. Now what that does is it gives you a little bit of squish, actually gives you some material to push against this other flat side and make a flat seal. Now that's one half of making these effective. The other half is your width. If you have, I guess I'll just draw another one here. If you have your 2mm round tube, what you're going to do is the bottom of your channel is going to be this 2mm, and the top is going to be a split of this same percentage, if that makes sense. So what you're going to have, sorry for my crude drawing here, I erase sometimes. What you're going to have here is a squish effect, right? So now this wedge, this 0.7 or the 0.25% that you took up here in slack, it's kind of like a trapezoid, right? It's going to squeeze this fat bottom, it's going to push it into here, and you're still going to have your 0.25 of your total 2mm protruding, and that's going to give you a long lasting seal that you actually have to pound in here. You'll take a little mini hammer and you'll cut it a little long, pound that in there all the way around, and then you will trim that just with a little bit of protrusion, not even a 1/16 of an inch. If you want to say a 32nd, a millimeter, I'm not sure, just enough to where there's rubber, contacting rubber inside of this seal. And that is the trick to getting the linear seal to work in your favor. And now that's only applied if you have these two halves and have multi-piece molds, obviously getting crazy with it. So remember, between 0.8 and 0.75 of your total diameter. So if you've got a 3mm or 4mm or however big of an O-ring that you decide to go with, that is an effective number that allows it to hold while retaining its squish factor and sealing appropriately, giving you lasting results. So that's that. So now we're going to start on the sealing aspect of the top portion. Back hammer goes left to right, goes like this, okay? So this outer ring, keeping all of the fluid contained inside, here is what is going to contact our linear seal. Now, the inner seal, it's just going to go on this surface. Now, the way that I print these for surface reasons, I print this upside down because the part that I want comes into contact with the good looking side of the 3D printer. As you can tell, this looks fantastic and phenomenal. While when you print this upside down, you have a scaffold. It looks kind of like that, as you can see. It makes this really bumpy, rigid surface. Now, with 3D setting, with your 3D printer settings, you can get pretty close to having this as smooth as possible, which is what I've done here, but it's still not good enough to actually fully hold liquid. So the only little bit of outside trimming or modification, if you will, is this is just Bondo. Go to O'Reilly's or whatever your favorite CarQuest place is and get you a tube of the auto body Bondo, and you just putty that on there, right? You're gonna just putty and then sand it smooth. Make sure you clear out your holes with a little drill, and these things last forever. They have great results. They seal up perfectly. You're just going to have really good results with going that route. But more on 3D printing and how to get like the best out of doing with what you have with what your printer is, and making sure that your settings are correct, because that is, whew, that is its own crazy wild adventure. So again, these slots for these O-rings follow, I guess I did it upside down, follow this same principle. I can turn this upside down now for all you kiddies at home so you can kind of see what I'm trying to get at. The trapezoidus here, your pocket, do those in 0.75 of whatever diameter it is of your O-ring. So the top also applies to that as well. This is a 0.75 wide with a full gap to a 0.75 wide exit up towards the top. Now these stay in here really well. These don't come out. You got to pick these out of here. You'll get everlasting use and sealage out of these. So now moving forward to the rest of what makes this top really nice, as I stated before, you have your tapers here with either this edge or this outer square edge being 0.02 millimeter or 1 filament pass short. Now, mind you, for the whole thing. We want the whole thing. The other portion of this, as far as removal goes, when this is all together and has silicone in it, it's going to be hard to remove this top, per se. Now, that's where these come in. These are jack bolt holes. These do get tapped with a tap to make them easier. I don't have a bolt on me, but a normal 10 by 125 bolt goes in this, and if you can't get this top off by hand, you put a jack bolt in here and this pops off. Now when you do that, of course this is all going to be together, right? And if you had your mold together, you would unscrew this and then pop this off of this center section, and now you have your wedges where you wedge it apart, wedge this piece out, and then pull, for me, my Filter Buddy piece out of the center section. As you go along, you kind of just figure out what you can and can't do as far as these go, as far as what you can like push on and how hard you can. Again, these are extremely sturdy, and if you follow a couple of these simple upgrade rules, you should be able to have, make some of these molds make hundreds of parts, which I have done successfully with the same ones. Moving on to kind of the coolness of the threaded part of what finishes up this mold's design is this threaded part here, right? So this keeps our orientation. Now these are 3D printed. These really aren't trimmed at all. They go together just like that. Two really big things to think about when you're trying to increase rigidity, or if you have to do something like this, is incorporating actual steel bolts into whatever it is that you have that's failing. So when you have a threaded on type like this and you tighten this down, you are pulling these threads up through this action to clamp this all together. And if you're relying on 3D printing alone, you will notice that these layers of the 3D printing, when subjected to a pulling force, such as that, they can separate pretty easily, especially if you have any kind of imperfection in the process of your 3D printer. So to get rid of that, or to subsidize it, or I guess mend some of that, here's the slug that comes out of here. So you can get an understanding of how far down this bolt goes. What that does is it threads in down here with a 10 by 125 actual steel bolt, and it compresses this whole top section from about here up. And what that does is it gives me extremely, this, you know, it gets beat around. If you drop it, it fucking snaps or does whatever. By doing that, these are extremely strong. These I have used for one mold hundreds of times. It gets excellent sealing pressure from the O-ring. You can reuse these several times. Really running into very few issues once you add this bolt. So if you're running into separation or structural issues, don't be afraid to re-engineer it and incorporate some actual steel into these to cut cost and to make these last for a very long time. So now the final part that I want to kind of address as far as will help you when you're addressing 3D printed threads for something like this. First off, start by inserting this bolt for sure. If you're over here trying to get this to work and it's tight, you can easily snap this union here if you do not have this bolt in here. So start with that, and then when you make these bolts or these bolt and nut threads, if you will, from the 3D printer, I use Fusion 360. And it does a really good job of rendering these threads and making them usable. Now with the 3D printer, the tolerances are pretty tight, and there's no effective way to trim these, you know, or file these to where they clear, right? Because these can be a real pain to get trimmed. Now, as you can see, this goes all the way on by itself. Like, it's very loose, very strong. And the secret to that is turn it into a die. As you can see, these cutouts here, these die dimples do exactly what you think they do. And as you get started from a fresh threaded print to a fresh nut, they're going to be extremely tight due to a bunch of different factors, mostly clearance and shifting issues due to your printer. They are going to be really tight. But what you do is you put these die dimples in here, and you start slow and you work it on. And the next thing you know, you're going to be going and 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 going. And as you go, you're going to see little itty bitty pieces or flakes of printed material coming out, and you go all the way down. Next thing you know, you'll be all the way there, and you will have really smooth, usable, effective threads that last and can do the job. So those are the major points to having a really successful 3D printed mold that will hold a liquid that you can also open up and extract. For me, it's a silicone filter buddy. Now, there are tons of ideas that I have as far as applying this principle to the next phase of the seminar, which is going to be what I call it's a jig. You can take this design, which is a squeeze and clamp style mold, and put it into a jig that can do 50 of them. Now 50 is quite a large number, but you can apply what I'm going to show you and what I'm going to teach you to one, if you want to use, you know, some all thread to clamp them together, or you can do 2 to hundreds if you really wanted to. If you wanted to get more ambitious than I have, my mold will do 49 at a time, which I'll get into more. But if you wanted to scale this to the hundreds, you most certainly could, and there's nothing stopping you. And you would have the efficiency to make pieces, open them up, have them be clean. You could immediately reseal them, put them back into the jig, fill them back up and wait for them to cure and make a profit or turn a business or whatever it is that you decide to do. So those are a vast portion of the tips and kind of the tricks that make these molds really usable, to be honest. I know it seems kind of simple and crude, but as far as the engineering that goes into, now there's other things I could go in about, just has to do with the angle of your tapers inside where your vents are, the size of your vents. These are 2mm vents. These are 2.5mm vents. And I noticed that I had to double my ventage. This is a old prototype version that only had one row. Up here at my outer edge, I was having a lot of bubbling issues coming out of here because the bubbles weren't evacuating. So I had to redesign my entire fleet of molds to incorporate double the amount of outer rings to have the proper vents. So whatever it is that you're going to design or develop, again, you're going to just want to take into consideration your mechanical aptitude and really think about what you're trying to produce, what your liquid fluid is going to do as you inject it, and make sure that you have a viable escape for it, as well as a plan to remove your product from your mold. Because if you have some overhangs or you have pieces and weird configurations that when you try to rip the piece or pull your part out of the mold, you're going to run into issues. Pieces falling off, cutting, tearing, or just not getting completed altogether due to just struggles of the fluid and the mold design, the mold type. So the simpler, the better with 3D printing, obviously. If you like this stuff, go ahead. I'm going to give some more tips and tricks as far as printer setup for the Ender 3. Once you figure them out, they are an amazing machine. They have amazing tolerances. And the fact that you can have one to your doorstep in 3 days for $200 and pull off precision to do this stuff back to back to back is really impressive. Like, I honestly can't believe that it's possible nowadays. It's the tech that we have nowadays. So if you like this, give me a follow, give me a like, give me a share. Please check out mm-manufacturing.com to see more about Filter Buddy and check out what I have going on with that. I feel like the dogs just came inside because the whole house just started shaking. Jesus Lord. So go ahead and head on over to mm-manufacturing.com. I will have more seminars coming up for 3D printers, for the jig, for the injection of the jig, and how you can turn this mold design into a semi-industrial, reusable, almost self-cleaning style mold to produce all kinds of things, whatever you really want to. So I appreciate you guys for coming to watch my videos. Again, I apologize if I ramble and I don't have everything kind of together, because there is just so much I could cover as far as failure and success and what to do, what not to do. I figured giving the example of my mold and kind of condensing what really makes it successful as far as a repeatable design. Because nowadays I see guys that they do 3D printed designs and they don't accommodate, the separation. They break their molds, or they're trying to do 1 or 2 piece runs. You have guys that do, the cardboard with the super glue or the hot glue guns, and, pour molds. What do they call it? Pour molds, producing one-sided pieces, flat pieces, kind of like the old metal castings and stuff. So this, I believe, is a real surefire way that you could make almost as sophisticated parts as you wanted, be successful in their production, low cost with your chaff and everything, and being able to step into a realm where maybe you want to produce a part, maybe you want to produce a tool, or you have an idea that you want to bring to light. That's kind of a scary, daunting task when people start throwing around patent words and production. You know, oh, we want a minimum order of 10,000 units, and you know, the mold itself for the machine costs 10 grand, and then you got a lawyer that tells you need to spend 10 grand, and it can become very, very daunting, and releasing a product can be extremely hard. So I'm going to tip you up here so I can get some more of my face, but it can be kind of difficult or a daunting task to really say, I'm going to go after trying to develop a product, make it, bring it to market, you know, produce it, develop it, manufacture it, and it can really be quite daunting. So I'm hoping that this gave you a little bit of excitement, maybe a little bit of a guiding light into, hey, I really can do it, because if you follow along and see what I have to say, you're going to see that it is totally possible. So again, thank you very much for following. Again, check out mm-manufacturing.com to see more about Filter Buddy and what you can use it for, and maybe it can be put in your toolbox. You never know. It can be a gift for your dad. If he's always changing your oil, like, keep him around for a couple more years. Get that hot oil off his head. You know, I'm sure he chews his nails enough. So again, thank you for watching. Please like, share for more of my other videos. I'm going to get over to explaining how the jig works. So let's go.